So hello everyone, welcome to my channel. Now in this video I am going to discuss the topic of refraction on the basis of Huygen's theory. Okay. Now suppose this line represents the interface of two medium. This is medium 1 and this is medium 2. Okay, and this is a wave. This is the direction in which the wave is incident on this surface. Okay, so this is the direction of wave propagation. Okay, now this is the normal, so this is angle of incidence. Okay, now see, according to Huygen's theory, the direction of wave propagation and the wave front, they are always mutually perpendicular. Okay, so if I draw a line like this such that this line is perpendicular to both these lines, okay, it is perpendicular to both these lines, then in that case this will represent a wave front. Okay, so see, this wave front, it is coming like this, and finally at this particular position this wave front is incident on the surface. Okay, it is in contact with the surface. Okay, so now one more thing, suppose let us name these points as, say, this is A, this is B and this is C. Okay, now had this ray or had this wave has come normal incidence, in that case this I would have been 0. Now if this I would have been 0, in that case, see, this wave front C point would have been at B. Both, see, this wave front will reach the surface at the same instant. Both A and C will reach the surface at the same instant. Okay, so that means this wave front, this direction will be along this direction. Okay, and this I is 0. Okay, now angle of incidence is 0, and this angle made by this wave front with the surface will also be 0. So this implies that these two angles are equal. Okay, so this is angle of incidence and this is also I. Okay, so angle of incidence is also equal to angle made by the incident wave front with the horizontal surface. Okay, now suppose V1 is the velocity in medium 1. Okay, V1 is the velocity in medium 1 and V2 is the velocity in medium 2. Okay, now this is the incident wave front. Now I have to find the next wave front. Now next wave front is going to be the refracted wave front. Okay, now by the time this ray travels from C to B, okay, now suppose it takes time tau. Okay, so if it takes time tau to travel from C to B, then this distance will be V1 tau. Why V1 tau? Because V1 is the velocity, tau is the time taken. Okay, now by the time the disturbance from C reaches B, the disturbance from A reaches somewhere here. Okay, now how will I locate the position? For that, velocity of in medium 2 is V2. Okay, the disturbance has traveled from C to B in time tau. Now in the same time, this disturbance from this point will travel a distance V2. It will travel a distance V2 into tau in medium 2. Okay, so with this point, with point A as center and V2 tau as radius, I will draw an arc. Okay, so suppose this is the arc. Okay, now from point B, I will draw a tangent to this arc. Okay, and then from this point A, I will draw a line such that this line is normal to this tangent. Okay, this is 90 degree. Okay, now what is the purpose of this? Okay, see, I've already told you, according to Huygen's theory, the direction of wave and the wave front, direction of wave propagation and wave front, they are always at 90 degree. Okay, now this is the, see, this point and this point, they are disturbed at the same instant. That means they are vibrating in same phase. And what is wave front? Wave front is the locus of points which are vibrating in same phase. So that means this is a wave front. Okay, and this is the direction of the refracted wave. Okay, so this direction of refracted wave and wave front, they are mutually perpendicular. So this satisfies the condition of Huygen's principle. Okay, so this is the direction of the refracted wave. So if this is the direction of the refracted wave, that means this angle will be angle of refraction. Okay, now as I told you, angle of incidence is equal to the angle made by the incident wave front with the horizontal surface or this interface line. Similarly, angle of refraction will also be equal to angle made by this refracted wave front with this horizontal surface. So this angle will be R. Okay, now we have this one right angle triangle ACB, another right angle triangle. Suppose we mark this point as D. And what about the distance of this AD? For this AD distance, I have taken the distance length to be V2 tau. So this AD length is V2 tau. Okay, AD is V2 tau. Okay, so now if I take this right angle triangle ACB, okay, right angle triangle ACB, I can see that sin I equal to BC by AB. And what is BC? BC is V1 tau by AB, perpendicular by hypotenuse. Now in this right angle triangle, sin R will be triangle ADB, sin R will be perpendicular by hypotenuse. What is perpendicular? AD by AB. What is AD? AD is V2 tau. So this is V2 tau by AB. Now if I divide these two equations, what do I get? I get sin I by sin R is equal to, see this AB cancels out, tau cancels out, so we have V1 by V2. Okay, now as you can see in this case, so we have sin I by sin R is equal to V1 by V2. Now as you can see in this case, see I is greater than R, the ray has bent towards the normal, so I is greater than R. Now if I is greater than R, sin I will be greater than sin R. So sin I will be greater than sin R, so sin I is greater than sin R. If this is greater than this, that means V1 is greater than V2. So this implies V1 is greater than V2. So velocity of light in the first medium is greater than velocity of light in the second medium. So this is just opposite to what stated by corpuscular theory. Okay, and this is the correct thing, and this was verified by Foucault, experimentally verified by Foucault. This is the theoretical proof, but it was experimentally verified by Foucault, who found that when a ray of light travels from air to water, the velocity of light in water is less than velocity of light in air. This was experimentally proved by Foucault. You might have heard this name while studying the concept of eddy current, because eddy current is also known as Foucault current. Okay, so this is Huygen's theory, on the basis of which we have explained the phenomena of refraction. Okay, now few more things to be seen, like if I take this V1 to be the wave velocity and tau be the time period. Okay, so in that case, wave velocity into time period is the wavelength, so BC will be the wavelength in first medium and AD will be the wavelength in second medium. Okay, so from this I can also write sin I by sin R is equal to BC by AD. BC by AD, AB cancels out. And now what is BC? BC is V1 tau, that is equal to lambda 1. So this is lambda 1 by lambda 2. Okay, so this is another result. We have sin I by sin R is equal to lambda 1 by lambda 2. Okay, so now as in this case, I is greater than R, so sin I is greater than sin R. So sin I greater than sin R, this implies lambda 1 greater than lambda 2. So what does this imply? See, when ray of light travels from one medium to another medium, and if it bends towards the normal, velocity decreases, wavelength also decreases. Both wavelength and velocity is decreasing. Okay, now frequency. Now frequency is V by lambda. Frequency is V by lambda. So as we can see, this velocity and wavelength both are decreasing. Okay, so that means the frequency will remain a constant. Okay, so in refraction there is no change in frequency, but since there is a change in medium, there will be a change in velocity, there will be a change in wavelength. Okay, both velocity and wavelength will change. Okay, now let us apply Snell's law to this concept. Okay, now suppose mu1 is the refractive index of medium 1 and mu2 is the refractive index of medium 2. Okay, so if I apply Snell's law, so it is mu1 sin I is equal to mu2 sin R, or I can write sin I by sin R is equal to mu2 by mu1. Okay, now if sin I is greater than sin R, it implies mu2 is greater than mu1. Okay, in this case, as in this case, I is greater than r. So I is greater than r, that means mu2 is greater than mu1. Okay, mu2 is greater than mu1, it implies that refractive index of the second medium is greater than refractive index of the first medium. That means second medium is the denser medium and first medium is the rarer medium. So when a ray of light travels from rarer medium to denser medium, it will bend towards the normal. And so the complete gist is, when a ray of light is traveling from rarer medium to denser medium, okay, first thing is it will bend towards the normal. I will be greater than r. Okay, velocity will decrease, wavelength will decrease, frequency will remain a constant. Okay, I hope this entire concept is clear to you. Okay, so my best wishes to you. Good luck.